conductor underlined by another resistor? Is it opposite of that? Is it, well, it's near surface conductor getting more resistive with depth? What sort of structure, or what? I don't want any information. You can't really define how thick things are, but just in terms of general, like resistor underlying a conductor or something like that. What do you guys think? Sorry? Okay. So that's two layers. And then another resistor, so gradually getting, so, okay. So we have one suggestion that's conductor, resistor, resistor. Anybody else? Anybody else think there might be a different number of layers? Sorry, just the curve. Yeah, don't pay attention to this over here. Sorry. No, it's actually not the answer. I don't, I don't think this will fit the data very well, actually.
I'd say, so yeah, conductor first, then resistor, then conductor again.
So,
Shallows, shallows.
so you're saying, okay, so first layer, conductor, okay. Okay, so that's one possibility that I could agree with. The other possibility is that this middle resistor is thick enough such that you're going conductor and then it gets resistive and it starts to plateau out because it's hit that resistivity. And then there's another resistor. So it could be a three-layer model going, as you suggested, going conductor, more resistive, more resistive. Okay. There's also this little thing right here. This overturn, this last 2 points, that might be indicating an additional conductor again. Okay. So just in that qualitative interpretation, we got 4 different interpretations, 3 or 4 different interpretations of what might be going on in the subsystem. So you see how difficult it is to do the qualitative interpretation, and why you really need to. And this also brings up, and we'll talk about this towards the end of this, a concept called, specifically in DC resistivity, called equivalence. And in general inversion theory, have you guys had any discussions about what inversion is, geophysical data inversion? How about geophysical data modeling? Talk about that. Okay. In modeling and inversion, I'll describe what inversion is in a moment, briefly.
Yeah, so typically you have the concept of weights or variances or uncertainties.
You can.
But like the tail end there, is that normal? Is sometimes you get noisy information,
Well,
is that reliable?
okay, so what Kendall's referring there to is a lot of times we hope to actually acquire data with some sort of statistics on it, okay? And what you would hope to see is you might have error bars on these. Do you know what error bars are? Where you take the data multiple times and then you, so if you had the time to do it, you could do the experiment 2, 3, 5 times, and then you would get some statistics on these data, and that would involve, when I say do it 2, 3, 5 times, that means taking the electrodes out of the ground, replanting them, doing the whole thing. Another way to get statistics is kind of cheating. It doesn't yield very accurate results of the statistics, I find, is if you just put the electrodes out there and you left them in this position right here to acquire that data point, and then you just acquire the data over and over without moving anything, what you'll tend to find is you can just sit there and what's called stack over and over and over and over until that error bar shrinks smaller than the size of that symbol, and it's not really giving you good statistics. Okay. So generally we only get good statistics if you really want to do the full experiment multiple times. And what I was going to, and we'll talk a little bit more about this in a moment, but just in the general description of what we were talking about here, is it 3 layers, is it 4 layers, is there a conductor at depth? That introduces the concept of non-uniqueness, okay? Which is, you haven't talked about inversion theory at all, and I doubt you will probably, I don't know if it's in the data. But there's this concept that multiple models will fit the data. So there's no one, well, there is one right answer, but it's likely the answer you come up with is not the one right answer, and you have to realize that there's uncertainty in the computerized interpretation that you come up with.
So Dave, what is that conundrum? Where did it come from?
This came from the software. Like, that's the way it's booted up, and well, I think it's a starting model to invert this data, maybe. Unfortunately, this is the way the demo comes. I would have liked this not being here in the demo. They're going to be using this for a homework problem, so we'll have to have you guys work with this a little bit. But that's way too many layers, number one, to explain this data set. So there's just issues with this, and I would have wished that it wasn't already done like that. But we'll deal with that when we're inside. Okay, so let me go up here. Shrink this down. Okay, so that's qualitative interpretation. You can see some of the issues with that. The more now with more computing power and whatnot, generally we interpret DC resistivity using this concept I call conversion. And you've talked about modeling data, okay? That's where you somehow, I don't know, have you done any homework problems where you've modeled, tried to simulate the Earth and generated a synthetic data set? For gravity or something like that? Okay, so you input some sort of density distribution and then simulated what the gravity anomaly would look like for that density distribution. Okay, that's called forward model, okay? Your input is some sort of property, physical property distribution, and then you generate what the data would look like for that physical property distribution. Inversion or inverse modeling is the opposite of that. That is, you give the computer algorithm the data, and it will give you either a property distribution that fits the data or a range of property distributions that fit the data. Now, inversion is very non-unique. Just mentioned that. That means there's multiple models that will fit the data. Therefore, depending on computing power you have available and the complexity of the physics of the problem that you're trying to model and invert, you can set up your inversion either just for giving you one model that fits the data or a whole range of models, and that way you get some sort of statistics of it and get some idea of the uncertainty in the inversion process. But this is just an example. This is using just an approach that gives us one model. Okay, it applies what's called a smoothing constraint to stabilize the inversion process, because inversion tends to be, you're inverting matrices that are basically close to singular, so they tend to be unstable processes mathematically. And so you have to apply some sort of constraint, and in this case we're applying a smoothing constraint that gives a property model back that's smoothly varying from one point in the median to the next, okay? So here's a dipole-dipole section of data that I showed you before, and this is the resulting resistivity structure in 2D that would generate that data set, or a resistivity structure in 2D that would generate that data set. So now you can see trying to interpret the dipole-dipole data set directly versus a resistivity distribution directly. It's easier to do this. Now we've got depth on this axis. I know it's hard to see, but this is 75 meters depth right here. And red is low resistivity and blue is high resistivity. And so now we're able to see where things properly are falling in the subsurface, okay? So we've got a conductive body here, a conductive body here, a couple near surface anomalies, okay, geologic noise that I kind of talked about earlier. But now we've got some ideas of where things are in the subsurface, okay? Here, this is once again, a pseudo section plot of apparent resistivity. This vertical axis is some sort of electrode offset, so it's not true depth. And this is apparent resistivity, which if you remember is the resistivity of a fictitious uniform half space that would yield the same values of voltage and current that you actually measure, okay? So this is just a representation of the data, but now through the inversion process, we're taking this data and converting it to some sort of estimate of subsurface properties, okay? Does that make sense to everybody? For resistivity, this is a nonlinear process, okay? Going from the data to the resulting distribution of physical properties. So there's it's very easy to do, it's very black boxish. You just read in the data into the algorithm or give the algorithm the data file, and it goes through and runs it and then returns an answer. And its simplicity of running that hides the complexity of the problem behind. So you have to be very careful not to over